Hello and good day. This is the second in a series of tutorials on the WaPORACT package available from GitHub. In today's tutorial I'll be showing you how to download rasters from the WaPOR portal. This is the tutorial 1A notebook available in the package. The WaPORACT package was released as part of the WaterPit project. And the goal of the project is to further improve access to the WaPOR dataset made available by the FAO. So, to run the WaPORACT package via the Jupyter notebooks, the first thing you'll have to do is start Anaconda prompt or command line. This tutorial does not show you how to install the package itself. That was covered in the previous tutorial 1. This follows on that with the running of the actual tutorial notebooks. So, first thing we have to do is conda activate WaPORACT, the previously built environment. Then once activated, we can change directory to the WaPORACT Git folder. You can also just access notebooks directly, but this is much easier as the notebook starts off in the directory WaPORACT where you can find the tutorials. Once you're in the directory, we can start the notebook. And that'll open in your browser. So, once we have it open, we can then move to the WaPORACT folder, tutorials, WaPORACT basics, then downloading from WaPOR. Now, to keep this video short, I will not be walking you through every single step that the tutorial covers, but feel free to read through all the instructions in your own time. The first thing that we'll have to do is, for downloading rasters, is to get an API token from the portal. So follow the link provided here. So I have skipped over the sign in process, but if you go to the WaPOR page, there'll be a sign in button here where you can register. Then once you've registered, it changes to the My WaPOR page. And when you click on that, you get into the options of My WaPOR. And if you click on Profile, you can scroll down and click on Generate API Token, which becomes Revoke API Token once it's been clicked on. And then you can copy that token over. So we're just going to record that in a notepad for now, for later use. Then you can close these pages once you have the token, and we can continue on. The next step I recommend that you take is you have a look at the automated folder structure as explained in the wiki of the GitHub page. The reason being is that WaPOR ACT package retrieves data in a standardized way, otherwise it would not be possible to automate it. And further details will be provided later, but this means that standard folders are created for the retrieval of the data. So what we can do now is import the actual WaPORACT package, specifically the retrieval class, and that'll go ahead and retrieve it. You can see it successfully printed the print statement, so that means it retrieved successfully. Once you have activated the WaPOR retrieval and got the token, we can download some data. Now, for the retrieval itself, you'll need to specify a WaPORACT directory, a shapefile path, and the level of data that you want to retrieve. WaPOR data is available at 3 different levels. For details, please check out the site. You also need an API token, a period start, and a period end date formatted as a date time object. that specifies the period for which you want to retrieve data. There are also optional inputs, but we won't cover them at this time, but please do go ahead and read them if you like. So, moving on to the actual retrieval, what you'll need here is to specify a path for the WaPORACT directory. This is where the automated folder structure gets built and where all data retrieved gets deposited. So I'll go ahead and do that now. So I've created a folder called WaPORACT runs in a location of my choosing, and I'm going to shift click for copy as path. And once you have the path to that folder, you can replace this section between the two arrows here, making sure not to keep the extra marks. So you've specified a WaPORACT directory. Next you'll need a shapefile path. Now we've provided one inside the WaPORACT package for testing, and that's the one we're going to be using here today. So all you need to do is replace this section here with the path to the WaPORACT Git repo. Again, I'm going to copy that path, or if you can also type it if you know it, and then just replace the quotes, and there we go. So then we're going to be retrieving data for level 3 from the period 2021-11. So that's the year 2021, the first month, January of the first day, to 2021-1, so the second month, February of the first date. Period start and period end always need to be formatted as datetime. Datetime is a Python type of object. It's very simple. Once datetime is imported, simply type datetime with opening bracket, the date formatted like this, and a closing bracket. The project name will be WaPORACT test, and API token will be the one we saved in the notepad, which we can then copy and insert here. And then we'll be able to activate the retrieval class. So the first time that you run this, it will take a little bit longer, as the retrieval class on initiation takes on a couple of extra steps. It formats the WaPOR catalog for the given level you're retrieving data for. So in this case level 3, and the catalog is an Excel or CSV file, which is stored in a standard folder I'll show on completion, that contains information on all the data you can retrieve from the WaPOR portal, as well as the codes used to retrieve it. So we'll just wait for that to continue. Okay, so we've made some progress. Now what it's done is it's created a catalog, and as it states here, it has outputted it to the metadata standardized folder of the WaPORACT directory we specified. Next, it is checking that catalog for information related to the data we're using to make sure that for level 3 the location is actually available. What it does also in the meantime is that for the shapefile given, it produces a bounding box for that shapefile and a bounding box shapefile, which also gets outputted to the standard location of the project. The reason for this is that the WaPOR data is at a different resolution, and it gets retrieved using the bounding box, so pre-clipped to that location of interest. That's why it's good to have a bounding box available to carry out that process. Now, the initiation class was successful. We can go on to check out the bounding box produced. See here, that's the coordinates of the bounding box and the shapefile path to the bounding box. Now I'll pause here for a second And I'm just going to open the WaPORACT runs folder built. And as you can see here, you have the metadata because they're not to a specific project. And there you can find the level 3 location shapefile specifying where level 3 data is available, as well as the catalog for level 3. If you were to run the code for level 1 and level 2, then those catalogs will also be added to this location. And the WaPORACT test, the actual for level 3, the actual data will be stored in these locations. For now, we have the reference and we have the bounding boxes here. So, moving on, let's actually retrieve some data. So, to retrieve actual data, the only argument you'll need is the data components that you want to retrieve. It is possible to provide more arguments, but if they're not provided, it uses the standard arguments already provided on class initiation, or the arguments that are automated, such as the return period. Now, I didn't cover this before, but the return period is the interval at which data is produced for the WaPOR portal for that product at that level. So there is some daily data available, but most of the highest temporal resolution of the data is at decadal. And then there's also seasonal and annual data available. If you provide a template raster path, then the data is also clipped and transformed to match the metadata or the template of the template raster that you have provided. If not provided, it uses the first raster retrieved as the template for all the rest. Alright, so let's retrieve some data. Now, in this case, we are not going to provide any other arguments for period end or period start, since it'll do it for the same ones as used in the class. So that's here. So we're retrieving data from the 1st of January 2021 to the 1st of February 2021. And the IOE name, also important one, is the subfolder where processed data is stored. In case no name is provided, it is auto set to no mask. Now, no mask means that no mask is used. If, however, the shapefile that you're using represents a new area of interest, you can specify it as a masking area. So let's retrieve some data for actual evapotranspiration. And it's going and downloading the data. This is done in two main steps: the retrieval of the URL for data retrieval, which takes the longest, and then the actual downloading and processing of the rasters retrieved, which takes a shorter amount of time. The first part takes longer because we're waiting on the response from the WaPOR portal. So you can see here we're retrieving level 3 data for the Gezira region, and for the data component actual evapotranspiration between these dates. And voila, the data has been retrieved. Next step we'll do is have a look at the data, as the download WaPOR rasters function of the retrieval class outputs the data in a specific format that consists of a dictionary containing the data components as the key if you download multiple data components, and then either the VRT path, so the path to a VRT produced that covers the entire period retrieved, or the list of rasters retrieved, which includes every raster retrieved for the period given. And you can access them in this way, or simply type retrieve rasters and it'll print the whole thing out with the print statement. So let's check out the data just to make sure it'll retrieved correctly. We then go to QGIS, and then we go here to the data folder where it's been put. Now the temp folder is empty because temp folder only retrieves data during data retrieval, and then if the retrieval and processing has been successful, the data in there has been deleted. If, however, the process fails, you may be able to find some temporary files kept in there for checking. In this case, the downloaded data is available here, and the mask data is also found here, including the VRT. In this case, it's a carbon copy of the download data because we didn't use a different mask. So let's have a look see. If we then load this data in, you can see here that the data is retrieved, and in this case we didn't use a mask, so that's the whole area. Now, just to show you what happens when you download data for multiple years, we're going to change the argument here for period start and period end. And then we're going to download some new data for the same data component to show you some of the things that can happen. So, nope, can't forget the comma there. So, when retrieving data, you can see first that the first three were very successful very quickly. That's because the file was already found. Now the package was built so that if you're retrieving data into the same folder structure as previously set and the data is already available, then it skips those downloads and continues where it left off, or more specific, where data is missing. Now this process takes quite a bit longer because you're downloading for multiple years in this case 1 year and 3 months. And you can see here that the download has now been split between 2 periods, since downloads are carried out per year to make it easier to see what is happening. So since the highest resolution in general is a decade, you can have 36 downloads in a year at most, and then the next year will have less as well. So that process took a little while. The more rasters that you download, the longer it's going to take. So I recommend, if you're doing this for a few years and multiple data components, that you set it running and go have a coffee or something. Depending on your internet connection, it can also take longer. So in this case, the download was split up between 2 phases, and the second phase is shorter, and both completed successfully. Now in this case, if we were to print this, we can see that a lot more data has been downloaded. Thank you for listening, and hopefully this helps you in retrieving data from the WaPOR portal.